Okay, so this presentation is more from a tutor's perspective. So I've called it my advice. Similar sort of thing though. Going to go through sort of the sections, what we're looking for in terms of marking perspective. So review each section and just make some comments. In terms of the forum, wiki work, we've only got 5 marks here. Part of that, you should email me what mark you think is reasonable. Okay, so this will demonstrate what's the word I'm looking for? An engagement with this exercise, and it will demonstrate that you're, a keen student, that you've engaged with the exercise, and you're reporting back to your tutor. So my advice would be to send me an email what you think is a reasonable mark, how engaged you were, or how you found the process difficult to cope with, maybe for some personal reasons. And again, say how you found an alternative approach to do this group work. So as part of that, to improve your marks, email me what you think is reasonable and send me a justification. That will also be something that you can then talk about and give you some feedback before your submission. For specifying the purpose, we've got 5 marks here. So things to avoid is don't repeat yourself in specifying the purpose. Do not be vague. Do not copy the wording or phrasing from the assignment book. So best approach would be not to cut and paste the assignment book and rewrite to avoid taking phrases from it. But the best approach would be coming up with your own words as you write out the purpose. Make sure that you've covered the main points. Make sure that you, essentially speaking, get it right. So the specification should say what is being investigated. That's fundamentally what we're looking for. Try and make your specification meaningful so that the specification informs the reader what is being solved. You're probably looking at about 2 or 3 lines here, and you're looking at 100 words maximum. In terms of creating the model, there's 30 marks here, where they recommend that you should try and break this down into, I think it's 4 sections, isn't it? So the first one is describing features investigated and outlining the mathematics. So it's 5 marks here. So for this part, you should not have any mathematical notation. You should not be mentioning features unless they're stated here. So if you've got any features elsewhere in your report, go back and make sure that you've inserted them at this point. State the features that you are investigating from your feature list. Give a quantitative description of your approach. So we're saying how things are solved. So I suppose we could use terms or like integrated and so on, but nothing formal mathematically. Explain why this is an acceptable first model. Review the outline so that it's as informative as possible. And review the outline so that it segues to the next section. Okay. It may be appropriate to mention what is not being considered as well. So that's something else to review, probably at the review stage. You might want to look at that. Segueing between sections is quite important. So this particular case, we're talking segueing from subsections to subsections. And you probably want to always have at least one line saying how you've concluded something and how this is going to inform the next section. Something along those lines. So from features, we're stating assumptions, 7 marks. At this stage, do not attempt to justify the assumptions and don't use any numbers in your assumptions. Have a numbered list of assumptions so that you can reference these when they're used in your modeling or in your write-up. You want to consider establishing a worst case scenario at this point, so that might be something that you could incorporate in assumptions, and justify if a typical case is being pursued. So ideally, for stopping distances, things falling off roofs, things crashing down, we're looking at the worst case scenario to make recommendations. There might, however, be a mathematical problem we're trying to solve where a typical case is the thing that we are looking at, so there might be a justification for that. Review the sanity of your assumptions. Okay, so do they seem reasonable? And review the internet for any established health and safety, for example, would be typical assumptions that could be applied. Got 5 marks for basically setting up our variables and parameters. So do not use conventional standard symbols. So for example, it would be a poor idea to have G representing the height of a building or the length that a car could stop, something like that, because G, the conventional standard is that that's going to be acceleration of gravity. That's what I mean by that. And again, theta or phi would typically be used for angles, so it would be stupid to use them for some other sort of physical property. Do not use non-SI standard international units, so we want to stick to newtons, we want to stick to meters, seconds, and so on. There might, however, be a reason that you do not want to use SI units. It's not it's SI, isn't it? Not yeah, SI, Standard International, it's French. There might be a reason that you want to use non-standard units, such as bar for pressure, for example. But yeah, okay. Do not give vague definitions. So you want to be quite verbose in what your definitions mean. So velocity, height, these are all a bit too non-descriptive and need more description in them. A table of symbols should be used. For each symbol, state its definition. As I said, make it reasonably verbose. Obviously, it's not going to be lines. I suppose a sentence this sort of length would be what we're looking for. And for each symbol, state any associated units that you're using. Check that the units are given and check that they're appropriate. So on the whole, we're using SI units. Check all variables and parameters that are used in the report are given. So you might want to do a scan through your report towards submission in case if any variables have crept in, or maybe that the variables that initially you thought were going to be used are not being used. Review the type of symbols used. So what do I mean by that? So whether it's going to be Greek letters, Roman numerals, and so on. Review subscripts and superscripts. you might want to incorporate main symbols with their subscripts, or you might have a list of subscripts at the end. Make terms as meaningful as possible. So U max is quite meaningful. Probably you're talking about velocity there. Probably you're talking about a maximum term there. Next, we want to move on to formulating mathematical relationships, and there's 13 marks associated with this. At this stage, do not use numerical values. Derive the relationships between your variables. Explain how the equations follow from your assumptions. So go back to your assumptions, and it'd be a good game to play, really, to try and order the assumptions so that they follow your derivation. So first assumption, second, and so on. Reference the use of the assumptions in your derivation. I like maybe something like A1, A2, or something like that, referring to each assumption, and then you can, in your derivation, so this is kind of a word derivation, you can then say how, because we're having I don't know, constant height, how this is going to be applied in your derivation. So that would be my A1 term, A1 derivation. Check each derivation is used, check each assumption is used in the derivation. Also, assumptions might be used later on, so this is something that you could be looking at in terms of assumptions being used later on. So they don't necessarily are all going to appear in this section and then the next section do the maths, but they're probably we would expect the majority of assumptions to be appearing here. Check unreferenced assumptions are referenced elsewhere. So if we have some assumptions that haven't been used in this derivation or in the next one, and do the maths part, check that they have been referenced somewhere else in your report. In formulating your mathematical relationships, include diagrams to help explain the derivation. Give brief explanations at each stage of the derivation. Don't get too verbose here, and don't assume that you need to prove standard terms or standard results. So you should be assuming some level of competency of your readership there, and you're more sort of explaining the narrative of your derivation as opposed to fundamental terms of how things are going to be solved. Note that there may be some overlap between formulating the mathematical relationship and doing the maths, and that you won't be penalized for getting this slightly wrong, or well, there's no wrong and right really, but you won't be penalized for doing something that might be considered inappropriate. Some of the derivation here, as I said, might end up appearing in the next section. Also note that the modeling process is being obsessed, and it's not really the model. So you can have quite a simple model. In fact, I would encourage you to, and don't feel, oh, my model is too simple, therefore I'm going to get low marks. It's actually the modeling process that you're being assessed on. So moving on to the next section, which is do the maths, 10 marks here. So this is where we're deriving our first solution. We're going to solve the variable of interest. Note that the solution may be a procedure with a series of equations. So we might not be able to boil things down to one equation to give us the answer for our variable of interest. We might have to go through a certain procedure. And of course that procedure might be numerical and analytical, or a mixture of both, in which case that's our model. Know that you should not use any data values even at this point when we're solving, although it might not be in terms of if we're doing an analytical solution. I suppose there might be a point that you might have to substitute things if you're looking at, I don't know, numerical solutions. Although that would be more a case of substituting in typical values for when you're wanting to look at graphs as opposed to the derivation. I can't really think that you would ever have to substitute in a real number to carry on the derivation. Remember that you should always be referencing back to your assumptions. So even at this stage, will be making heavy use of assumptions and working through our list and ticking them off. So here, draw the graphs with typical relationships, and as I said, this might be a stage where you have to, let's say if you want to do a computer plot of your relationships between your variables, that you might have to substitute in parameter values. But it'd be better to do sketch graphs based upon what you think how the variables should vary against one another. Note that if necessary, as I said, typical values for parameters might have to be substituted to achieve graph plots. Moving on to the next section is interpreting the results. So we start off here by collecting parameter values. More than likely we're going to turn to getting data from websites, so we need to reference that data, tell me which website things are coming from. Parameter values might also involve performing simple experiments, partly to get the parameter values or maybe to test them. Hopefully you can do some sort of experiments and that you can then put them in your appendix section. Describe the mathematical solution. So substitute the data into your model to find a solution. And from that, give a lay-by description of your solution, which might include instructions, which relate to guidelines or a worst-case scenario that you would want to give to a layperson. Here, make sure we give as many graphs and table results as possible, and then move on to find predictions to compare with reality. So what predictions can your model make, and what parts of your model can be tested? Okay, so these things that we might then move on to the next section in terms of evaluation. For the evaluation of the model, 15 marks, we're here getting our final results, and we're going to get some data to compare them with. So again, do not forget to reference things. So it's a tendency here to stop into referencing either your results, so you might require some self-referencing here, or what other sort of referencing, so referencing for data and so on. So collect additional data that you can directly compare with your model. Okay, so we're looking at the final result data that we're doing a back-to-back comparison with. You might want to use some internet data here or some third-party data, but it's more likely that you will want to consider doing some mock-up model experiments, or that you consider doing real-scale model experiments or similar scales. So for example, a real-scale model experiments, let's say if we're looking at things falling from roofs, would be actually if you had access to dropping something from a roof, then that would be a possibility. A similar experiment on a big scale, but more plausible, would be maybe dropping something falling from a garage or from a shed roof. Tabulate, plot and graph comparisons where possible. Okay, so we've got experimental data, we've got solutions from our model, so we should be able to tabulate them. Ideally, we could maybe do some plots or even graphs to compare the results. So that's moving on to this section here where we're comparing model predictions with the collected data. At this point, you might want to discuss a particular experiment that you couldn't do. More than likely that you couldn't do dropping an object off a house roof, and then you can give an explanation why that wasn't possible. Detail experiments that you would have liked to have done but you didn't do. So slight difference here between experiments that you cannot do because you cannot have access to do them, to other experiments which maybe would have liked to have done but maybe didn't have the time, or you needed someone else or video equipment to catch the results and so on. So here we should at this point have some results that we can do back-to-back comparisons from the experiment and the model, and we want to start criticizing the model. So based upon the tests that you've performed, how's the model handling and how's the model performing? So let's review our assumptions, review each assumption in turn and consider its significance. So depending on our criticisms, what significance could each assumption have on improving the results? Identify which assumptions, if introduced, will improve the results. So if I was looking at car braking and my braking distances in my model were longer than in reality, then I would be maybe looking at introducing air resistance, but would that have a great significance? I don't know, probably not. But that would be a valid assumption to introduce that would improve results. Revise the model. So we've got a good idea of what assumptions that we might want to use that will revise the model and improve things. So the first thing to do is to decide whether the model does need a revision. You could maybe get results which are pretty much bang on. In that case, we're still going to write up this section, but you could probably be looking at how you could simplify the model. Okay, make the procedure easier to understand, or incorporate into a spreadsheet or something like that. Decide whether you need to revise the model. More than likely this is going to be the path that you take where you're over predicting or under predicting, and in which case you want to identify which assumptions that are significant or not that would improve your comparisons. Make sure that you review all of the assumptions in turn, but do this very concisely. Describe your intended revision. So list any assumptions that are going to be revised and explain the new assumptions that will be used to replace them with. Finally, we've got 5 marks at the end where you want to summarize your modeling process. Very important here not to introduce anything new. Okay. Do not go over the word count for this particular section. It's not very much, I can't recall if it is top of my head. Describe the performance for your first model and detail any attempts that you did to try to improve it. Comments on the modeling process. Okay, go back to your specification and state how you have addressed it. So go all the way back to the beginning of your report, dig out your specification, and hopefully you've achieved whatever that specification is. There might be a bit of a report writing reverse engineering here, so you might want to go back and slightly tinker with your specification at the beginning. Finally, find some way to criticize your model in some way. So don't avoid it and say everything's perfect. Find some sort of criticisms of your model and report that to the reader. For presentation, there's 10 marks. Sort of thing that you're looking to get top marks is that the final value should be typically quoted to 3 significant figures. Use what's appropriate, but on the whole for engineering solutions, 3 sig fig is considered the most appropriate values. There might be some reasons why 2 sig fig should be given. Review your mathematical notation. Everything looks good there. Good equation editing. There's no typos crept in the derivations. Define any symbols that are used and that were introduced in the derivations. So there might be some local terms in a derivation used, some temporary terms, but that should then be, you should be able to find some commentary where you've said let this variable equal these properties or these variables that clearly stated in the derivation. Reference any formulas or source derivations that are used, and ideally reference them from the book. Give concise comments and explanations throughout your derivations, but don't go into details that you're proving the fundamental maths here. We're more interested in the narrative of the derivation itself. State results and follow up with conclusions or comments. So whenever you get a result, whenever you show a table, whenever you show a graph, pretty much every time you want to follow up with a comment about the graph or a conclusion about the data. So don't ever finish a section with a table, graph, plot, whatever. Always have a comment or a conclusion about what that table's telling me, and you probably want to use that comment partly to segue to the next subsection or section. Keep your drawings nice as possible to improve your presentation mark. Have diagrams and graphs, and make sure your drawings include figure captions. Email me any questions you might have. I'm going to run a tutorial on the cluster tutorial system, 8 PM this Sunday, so I'm available there for a tutorial. Okay, thank you.